Hello everyone, this is Ali Raza. Welcome to the Mentor Code Lab. In previous episode, we started talking about Turtiworty's implementation of the block entity properties. And inside block entity properties, he had this tick logic for the block entity and then fields. And I said that in the next video, we'll talk about tick logic and we will see what is going on. Now, between the end of that video and starting of this video, I contacted him and asked a simple question. Again, this is me. And I said that I understand the code clearly, but I can't figure how I can utilize them. Starting with an example of a block entity that generates a crafting logic and using a process and energy. How can we utilize the tick logic and tick operation? Now, Turti had answered that you can't, and that's what I'm not utilizing them. Previously, he said that he's dropping parts of the implementation because he thought that it's not a good idea. One of the reasons is that they will use lots of lambda. And here is my answer to him that, hey, let's figure out things. I think it's useful, but I think you are doing things wrong. And this is my example of a process. Let's talk about this for a minute and then we will go back and look at his code and figure things out. If you want to craft something, first, we want to see if we are using energy or not. If we are using energy, then we should see if we have enough energy or not. And if we have enough energy, then we want to make sure that we can craft or not. For example, if we are free and we are not crafting, if we are not crafting, we should see if we have a recipe or not. And if we are crafting, then we should see if the process is finished or not. And if the process is finished, then we want to craft. If the process is not finished, then we want to increase the processing numbers. And these are the boilerplate that we almost do all the time in every machine that has a progress. And they may use energy, they may use fluid, anything in there as a combo. This is the thing. And if we can dissect these steps inside their own modular classes, then we can put them in sequence or in any other combination, and then we can utilize them. At the end, I asked him that, hey, are you familiar with behavior tree concept for any game NPC API and making the AI, artificial intelligence of the characters in game? If you are not, please watch behavior trees, because let me talk about behavior trees. This is a behavior tree. Now let's take a look. We have a selector node, and the selector will choose one of the two branches, mainly the first branch. If it's successful, it will return. If it fails, that is when he will look at the other branch. Now this branch has a selector again, means that it will execute the left branch. If it fails, then it will go for the second branch. However, this branch starts with a sequence node. Now the sequence node is different. It will execute what it has in order, and it will return only when all of them are successful or when one of them is failed. And let's say that these two tasks are successful. Then the sequence will be successed after the flee is success. And it will come back to this node. It says that, okay, all my children are successful, so I'm successful. He will return back the success to the selector, and selector says that, okay, this branch was success. That's enough. I will return success. And the top node says that, okay, this branch was successful, so I return success, and the AI will finish its job. Now take note, he shows it as a task, but the name suggests that this is a condition node. By the way, each one of these boxes are called a node. Now, the condition node will check a condition and returns true or false. And if this condition is true, then the sequence will say, okay, go back to the next task. If this condition is failed, the sequence will fail. It will go up and it will go to the second condition. This branch actually is like an else branch for this can flee condition. And utilizing these nodes, we can go and do very complex system based on the logic. Now, this looks really similar to what we want to do. Imagine this. Let's do it this way. Imagine that we want to see if we can craft an item. Or here we want to craft an item actually. If we can't craft an item, we may want to do something else. I don't know. I don't care. If we can craft the item, we want to see if we can use the energy. So we ask, can we use the energy? If it says yes, then we want to have another condition. And here we will have another sequence. The condition node here, do we have enough energy? Says yes, then we want to use the energy. And after using the energy, this sequence will become success. Now, this one is not a selector, this one is a sequence. So we move forward and find the next node. Okay, up until now, we made sure that we can use the energy and we have enough energy. We decrease the energy amount, so we start crafting. Or alternatively, we want to see if we have a recipe and we are not doing any recipe right now, Then we go for the next branch, that is, do we have the energy? And if we have the energy, please reduce the energy, because we already have a recipe ready for us. Then we move forward for another node, and in this node, we start the process and we return success and we go up. Now, we will have another thing here, for example, checking if the process is 0 at the start. So if the process is started, this will return failure. Then we will have here a new node that says that, okay, we are processing something. Please continue the process. The first one will be, I don't know, maybe a sequence. We check if the process is finished, then we craft the item. If the process is not finished, the sequence or selector actually here will go for another node, and it says increase the process. So as you see, this is really close to having a behavior tree. Although we are not really creating a behavior tree, but what we want to do is really close in the concept of a behavior tree. Now, in any behavior tree, we have nodes. Each node is responsible of handling something. For example, here, enemy or flee is a node, and it's a selector. Then flee sequence is a node. Can flee is a node. And this whole thing is called the tree. And each branch has leaves at the very end. So end leaves are most of the time actions. So we have sequence that starts doing one branch. When it's successful, he will continue to the next branch. Okay. Now, instead of sequence, as you saw, we have selector. Now, selector is not showed here, but this is a fallback, and it's the same thing, selectors. So if the first branch fails, that is only then that the second branch will work. In Minecraft process on the ticks, we won't have parallel. Basically, parallel will create threads and run each branch on a thread, and at the end, it will collect all of the results and only return the result of every one of them being successful. Then we have decorators. We will not talk about decorators here. We have two different execution nodes. One of them is condition node, that's if conditions for you, and then action nodes that are executing methods. These action nodes are actually doing something. For example, increasing the process, reducing the amount of energy, resetting the process, or I don't know, maybe finalizing the crafting and putting the item stack somewhere, removing item stack from another place, and stuff like that. Okay, so now that we understood a behavior tree, let's take a look at what a tick logic in the current implementation, as Turti had done it, is working. He is accepting a list of tick operations, and he calls it operations. Okay, at each tick, he will execute the whole tree. Now, here is it. Here is something that I will talk about later, fields here, but at each execution, he will go through this list of operations and execute each operation one after another and then finish. Take note, he doesn't care if the first operation is successful or not. He will move to the second one, move to the third one, move to the fourth one, okay? And he doesn't care about what is the operation itself. It's just telling them that, hey, please operate, okay? Now he has a builder. He'll talk about the builder in a few minutes later. But let's take a look at this tick operation as an interface. All it has is the execute command. And he is creating some extension classes that extends from iTick operator. For example, an empty class that executes and does nothing, or a default class that just accepts the block entity and field inside itself. Okay, operation here is just a by consumer, so it will execute it inside by consumer here. The conditional will do something else. He will check if the condition is met, then he will execute one thing. If the condition is not met, he will execute the second thing. The sequence will have a list, and inside execute, it will run each one of them and execute the operation there. A repeat will have a for loop that executes one operation more than one time and then go up and finish itself. While is checking a condition, and as much as the condition is met, it will execute the operation without going out of the tick. And delayed, of course, is delaying the execution by the tick numbers, and then at the proper tick number, it will execute the order. Now, if we call back what we learned from behavior tree, it looks like the tick logic itself should behave like a tree, okay? It's the tree itself. Then why do I see add operation, condition, sequence, repeat, while? Yes, we can do it, but there is a better way of adding things to this list in a proper implementation close to the behavior tree. Then again, a builder. Now, why do we need the builder is that normally you will generate this tick logic at the constructor level. So for example, we will have something like this. A class, let's call it test, and this class is extending block with entity, okay? And then we have a constructor. And yes, I should implement some methods here. Let's implement it and then ignore them. Now, at the constructor level, instead of this setting, you will say new BE settings, okay? BE properties, sorry. Let's remove that part, new BE properties, okay? Now this one is asking for the type, and the type is test. That's it. Or let me see, BE properties. Yeah, it should extend this guy. So let's extend this instead of our own block entity, okay? Let's remove that, and this is the type of test. Please behave. Let's remove and implement methods. Bye-bye. Create the constructor. This is what we want, okay? So here you see that we are asking for type, pause, and the state. Then we can say, for example, let's say that we have a block properties, okay? We would say this dot block properties equals to new, actually this dot properties. It would be equal to new BE properties this, then we would chain things, dot tick logic. And you notice that tick logic is asking for a builder, okay? And this builder is just, actually we would say tick logic dot builder, okay? And we would get this dot add operation, something like that, okay? Now I should remove these, okay? Add operation, and yes, I know that we have problems here because these are not static. And that's another thing that I should think about it. But after having the constructor at some point on tick, and I know when, it's the very first tick, we would call builder.build, okay? Or we can even call it here. So the builder.build, and this will return something, okay? As a tick logic. And we have assigned a tick logic to the properties. And here, for example, we would run the tick logic, whatever way we want to. So if we have something like this as an example, then here's a question. Do we really need these? The builder is responsible of adding nodes to this list. Now, the way he is doing things is that he's assuming that each node should work after the other one. Basically, he is not doing a selector. All he is doing as the general top level is a sequence that will run each node after the other one. And he doesn't even care if the previous operation is a failure. So if our block entity does not have enough energy, he will ignore it. It will go to the next level. And this is wrong. Also, the tick operation itself will execute with a block entity and a field. Now, what is a field? Let's take a look at that and fix things here. Block entity fields is, of course, a map of a string and block entity field. Let's go there. It's just the default value, a getter and setter. We had covered it in previous video. But wait a minute. All we are doing here as tick operation is that we are assigning a value to a block entity and then executing something on it. For example, the conditional. It says that if the condition is met, please execute on block entity with these fields on one operation, okay? And then if it fails, then the other operation should execute itself. And again, let's take a look at these. Else operation is an ITIC operation, okay? So we have to find a way to utilize these as we go forward. Now, I know why did he drop the idea, because a behavior tree like system, and I'm not talking about the behavior tree itself, but a system close to being a behavior tree is more complex than just having a tick logic and a list of nodes, and then each node has an execute command and just get done with it, and then we define some nodes. This is much more complex than what he started, and I think he was not thinking about a behavior tree, because if he was thinking about a behavior tree, the whole thing would be different. The problem here is with the behavior tree is that each node should be aware of its children, the connection with the children, and the order of executing its children. And each of these children should go down and execute something and then go back to the other thing. And when it's done, it will go back and check itself. And then when he is successful, he should be aware who is the parent. So he will inform the parent that, hey, I'm successful. And he says that, okay, this one is done, then I need to execute this one. Now this one returns success, this will return success, this will return success, and the whole tree will become success. The root will return success and reset itself. The concept of having leaves and moving through leaves and finding the relationship between the child and parent is very similar to a behavior tree. Now, do we want to have it or don't we want to have it? In my opinion, it is really doable. It would be nice if we had done something like that that, but this is not the proper way of doing it. So I will nuke this. I'm sure that 30 is just agreeing with me. The way he was implementing it is not proper. And this is just a list. I will not do it. Actually, I will not even keep the tick logic as a record. I will remove tick operation and tick logic, if I find it, from this system. Boom. And then I will add an interface and I will call it I tick logic. And this interface will accept a T actually that extends the no screen updatable BE of type T. And all I'm doing is calling a void tick. Okay. And actually, I'm not sure if I want to send in the client or not, but I will keep it as it is. We will come back to this later. So whenever I want to go back to the block properties, now this is I tick logic and of T. Do I want to have any fields there? Maybe, because you know what? This can be helpful. Okay. And then I want actually this is U extends this, and here will be U, and I will call it fields. So now I will have the tick logic, and I'm not gonna have any of this actually. Wait a minute. T and that. Okay, builder. We don't have builder. So I will remove this. I will say I tick logic of the T comma that, and instead of doing anything else, I just assign the tick logic and get done with it. Now here is the idea. I will have my own classes that implement the iTick, and I will write my own logic inside the tick. Now block entity fields is a nice one to have because now I can get a field and add a field, and this is a list of fields. This is the concept of a blackboard inside the behavior trees. Now this behavior tree, for example, as general, may want to carry some variables, and normally in something like Unity 3D, you will see a window here that contains different variables, and these variables are available to each and every one of the nodes inside the tree. So each one of the nodes can retrieve the value here, and this will be our fields, but I'm not gonna add the concept of leaves right now. All I think is that I will have something like this actually. Let me give you an example. I will have a test, and this test will implement I tick logic of, for example, test BE, comma, my fields, okay? And then, of course, I will have to implement the tick logic. You will see that I have test BE and my fields as the field and is in client. And now I can say if not is client, then do some things. And here, let's add a class, and this is my fields, extend fields, whatever. Now here I can say that, hey, I want to have fields dot get field, the name, I don't know, energy, and dot getter dot, I don't know. Now that will return the, wait a minute, comma. The type is integer dot class dot, I don't know. I will have to change things here because as you see, I can get the block entity, I can get the default value, I can get the getter for things, get getter dot. This will retrieve the block entity, and that's it. Basically, I don't have any way of retrieving the value. But hey, I want to get field int called energy, and that's it. So get field integer needs a name, and then the block entity. The block entity is the block entity that we have. That's it. So I can assign it to, I don't know, var energy amount equals to that, and then I will say if energy amount is greater than 0, do something. This is my logic. Of course, we have tons of errors here, and yeah, I need to do things here, work with this and implement the class. What's that? Tick block entity T, because yeah, the block entity is not being defined, but that's the thing, I can have this class as test that is implementing this, and then whenever I want in properties, I can assign it into tick logic. So at some point else, I will have a BE properties of type test BE, yeah, get properties, or I don't know, no, let's call it properties, equals to new B properties of whatever, and then as you see, tick logic is my test, is new test, and that is exactly how it will work. Now, every time it finds the test and I want to tick, I can just call the tick method, and I will send the block entity here at some tick point, and I will have some fields that I will send in fields, or I don't know, whatever, and then I will check if it's client or not, or actually, instead of this, I can send the word if I want to. That's a better thing, and I will call it word, and that's it. So I can say if the word is client or not, and this is how I will start thinking about a tick logic as the simplest way possible. Now, if I want to work on top of this, if I want to behave like the implementation of something more complex like a behavior tree, I have to sit back, put time and effort inside thinking the process, inside adding the code. And yes, I will add the to-do here, add a system close to a behavior tree. But this will happen much later. Right now, all I need to do is to generalize the idea of a tick.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.